Hey guys, we are going to talk physics. This is our first lecture on physics. And today we're going to talk about velocity, acceleration. We're going to talk about distance, displacement. We're going to talk about some words you may not have heard, or maybe you've heard of these words, but we might use them a little differently. The whole idea with this class will be for us to break things down so that it's not as bad as you think it was going to be. It's not. Physics is a great class, and a lot of students end up finding that they love physics better than any other science they've had. But the reason is we're going to be able to break things down and make things a little simpler for you, and it'll be a lot easier. So let's begin. Let's first talk about position and displacement. Position versus displacement is going to be, first let's talk about this position. Position is where you are, okay? We're going to give it the letter X. And in physics class, we have any topic we give, really, we talk about, is going to be given a letter, a variable. So position is given the letter X. Think X marks a spot. All right? So position is going to be where you are. And we usually have to assign a number to it. So position is if I'm standing 5 meters away from where I started, or where I said that my home base is, well, then my position would be 5. And now the units for position are meters. Okay, everything has units. All right, and units are really important when learning and going through physics. You need to keep an eye on the units, but you won't have to memorize it. Okay, that's an important thing to remember too. Is there will be no memorization with units. All right, so position, X marks a spot. If I say I'm 11 meters away from home base, then my position would be X equals 11 meters. Okay? Now, displacement. Displacement, you might have heard, sometimes you see in the news the word displacement talking about a family was displaced from a fire. Maybe certain people in a country had to be displaced from civil war. So the word displacement is used outside of physics. But in physics, it's talking about how far away you are from your home base. Okay, how far away you are from your origin. So displacement is going to be the difference in your starting position and your end position. Okay, you could say XF or X2 minus X1. XF would mean X final minus X initial. Okay, now we could also go fancy. If you remember chemistry, you remember delta, right? The change in delta. Delta means the change in. So we could do delta X as in the change in position. Or we could even use the letter D, but we're going to have to be careful because we also use the letter D, or we have to be careful about distance and displacement. They're a little bit different. I'm going to talk about that next slide. Okay, so displacement also would be X, but we'd say delta X, and the units would be meters, just like position. Okay, so there you go. 2 new words for physics. Next thing we're going to talk about is the difference between distance and displacement. Distance versus displacement. Distance is just how far you go. Okay, it's what your feet feel. If you were walking and I go this direction and then I go around and go the opposite direction, my distance is going to be what my feet actually did. And my distance would be, didn't care about direction. Now, displacement is different. Displacement, again, was how far away you are from where you've been. So sometimes they can be the same thing. If I walk in a straight line, my distance and displacement might be the same number. But as a physics teacher, I'm legally obligated to make sure you know the difference between distance and displacement. Okay, and give you some scenarios where they're different. Okay, the first one, think about like a rectangle. Let's say I go up 1. I walk around a table. I walk 1 meter around a table. Then I turn and I go 3 meters. And then I walk down the other end of the table. And then I turn around and go back 3 meters. Okay? My distance would be what my feet actually walked, which would be 1 meter plus 3 meters plus 1 meter plus 3 meters. My distance would be 8 meters. But what about my displacement? Well, think about it. If I start and stop in the same spot, my displacement is 0. So my displacement and my distance got me 2 different numbers. Okay, remember that distance is how far you go, and it doesn't care about direction. Displacement, the fancier words, means you got to think a little better about it. Okay, displacement is just how far you are from where you started. And sometimes that could be 0 or it could be a different number than your distance. All right, so that's the first thing. And honestly, that's going to be the first thing I quiz you on is the difference between distance and displacement. I might ask you and give you a scenario. They went one way, they went the other way. What's the distance? What's the displacement? Another scenario. Here you go. What if I walked 5 meters in one direction? I turn around and I go 3 meters in the other direction. Well, my distance would be 8 because it didn't care about the direction. My displacement would be 2 because if I went 5 in one direction, the opposite direction is basically like it's negative. So 5 minus 3, I'm 2 away from it. All right, so there's another scenario I could ask if you know the difference between distance and displacement. All right, average velocity. Velocity in general is just how fast you're going. Okay, similar to the word speed, although in this class speed and velocity are a little bit different. But velocity is how fast. All right, but when we talk in physics class, velocity also has to have a direction to it. So it's how fast in what direction. So if I say I'm going 5 meters per second that way, okay, or east or south or whatever, that direction is important to make sure we're talking about velocity. Even plus or minus, to be honest. Or up. Up is a direction, down is a direction, okay? But velocity has to have that direction part to it as opposed to speed. All right, I'm going to talk about the difference more soon. All right, the units. Again, I told you units are important. If you see meters per second, m/s, meters per second, are the units for velocity. So you know you're dealing with velocity if you see those units. The formula will be average velocity is equal to displacement over time. Now, this is not a great formula and it won't be used a lot down the road. But just to give you a general idea of velocity, we're specifically talking about average velocity. If I walk a certain distance, okay, I want to get my displacement, how far I am from where I started, and divide by the time it took me to get there, and that will be my average velocity. Okay? All right. Now, here's the difference between velocity, and average speed. Average velocity is going to be displacement over time. It cares about direction. Average speed is going to be distance divided by time. Okay, so my displacement is going to be, think about the scenario of us going around in a box. Okay, I start here, I end there, my displacement's 0. So that means my velocity, average velocity was 0. My speed would not be 0. Okay, I would add it up. My speed would be my distance divided by time. So it would be the 8 divided by the time it took me to do it, as opposed to 0. Okay? All right. Now, here's a question for you. 2 questions. I want you to think about these questions, pause it, think about it. 2 questions for you. 1, can velocity be 0? Okay? The other question, can it be negative? All right, so if you need time to think, you can pause right here and think about it. You done? You good? All right, so what do you think? Can velocity be 0? The answer is yes, right? And we just had the scenario. If I started and stopped in the same spot, my average velocity was 0. All right? Can it be negative? Well, if I go in one direction and say that direction is positive, the opposite direction will be negative. So just so you know, in physics class, anytime you're given a negative number, negative answer, whatever, negative just means direction. So we'll always have positive negatives, but negative just means the direction. And it's going to be whatever opposite the positive direction was. Okay. All right, next question for you, or next slide. Here we go. Acceleration. Acceleration is different than velocity. And a lot of students at first get tripped up between acceleration and velocity. They're completely different. Believe it or not, you cannot feel velocity. Think about being on an airplane. You're on an airplane, you're going very, very fast, right? You might be going 300 miles an hour. Does it feel fast? No. Okay, even in your car, if you're sitting in your car, you got the windows up, AC going. If you're going fast, you don't feel like you're going fast. What you feel is a speeding up and slowing down. And that's acceleration. Acceleration is your change in velocity. Okay? So, Acceleration, another way, so how do you feel acceleration? Well, if you're sitting in your car, right, you feel acceleration in your butt. You feel acceleration as you lean back into your seat. Okay, so you can feel acceleration that way. If you have a tassel hanging from your rear view mirror, right, as you accelerate, you're going to see that tassel swing back. Okay, if you slow down, that tassel is going to swing forward. So that's acceleration. That's different than velocity. They're two different things. All right, now I want you to guess. Try to see if you can guess what the equation is for acceleration in terms of velocity and time. So pause it here and let me know what you think. Okay, are we done? What did we come up with? Let's see if we got the right equation for acceleration. The formula for acceleration is going to be the change in velocity over time, delta V over delta T, or over T. You could say delta T, it doesn't really matter. All right. Now I'm going to tell you that the acceleration formula and the average velocity formulas I give you are not going to be ones that you even want to use on tests or anything like that. We're going to have more specific equations, and you're going to use those down the road. But I want you just to see these and use them just to have an idea. They're really more definitions. Real equations are going to be coming down in the next lecture or so. Okay, so there you go. The formula for acceleration is change in velocity over time. We use the letter A for acceleration, and the units, again, were meters per second squared. And don't get tripped up, and I forgot to talk about it. Don't get tripped up with that meters per second squared. You can think of it as a stamp. Okay, meters per second squared is just telling you what the number means. It doesn't mean that you do anything to the number. If you see meters per second squared, don't think you need to square the number. It's just a little stamp. It tells you what to do. Okay? All right. Last thing for this lecture is I want you to think about a very important list. I want you to think about a way to list out all the things you have. And this is going to be extremely helpful as we move along and we have word problems. Okay? Word problems, you hear word problems, a lot of people freak out. You won't have to freak out at all. But you want to use the tools. And this is a very, very helpful tool. Again, I don't know any teachers that expect people to memorize things. So if you have my students would have a yellow sheet, maybe you have a note card, whatever it's going to be. You want to have a list so that if you read a question and say, I don't know what they're talking about. If you see numbers and units next to them, you can say, wait, well, I don't know what they're talking about, but I see 5 meters, and I know that that must be position or displacement. And you can write that down. Okay, I'll use XF, final position or displacement. Okay, and I'll explain that way later. But whatever you use in your class, you could say, all right, well, if I see meters, then it's going to be this. Okay, time, always uses the letter T. If you saw anything with seconds in it, you can say, oh, I know that's time. Now, another part of that is the question. What if you see how long does it take to do something? Okay. I noticed that with some students, when you see the question, how long does it take, they see right away how long, and they think they're talking about length or distance. But how long does it take means time. So you need to be careful, but that's why we have this list. You could just list it out. How long does it take? Put that in the column. Those questions are there for you. So if you see the question, how long does it take, you look on your important list and you say, oh, they're talking about time. I see seconds. My answer needs to be in seconds. All right. Velocity, we're going to use the letter V, and that's going to be meters per second. All right. And that could also be how fast. It could be what is the velocity, but it could be how fast. And then finally, acceleration, we use the letter A, and that's going to be meters per second squared. And notice that's different from meters per second. Okay. Acceleration and velocity look like the same units, but they're different. All right. So we'll add to that list as we go along. But this is a very, very important thing to start with. Okay, that's it for me. Thank you.